Hello everyone, this is Evita from HFTP Asia Research Center. Welcome to today's webinar, Hotel Wireless Network and Security Issues. This session will look at Wi-Fi technology trends and best practice for hotels and resorts. Effective use of technology, especially Wi-Fi, is essential to enhance the guest experience. Several questions will be discussed, such as how the Internet of Things will impact hotel operations and hotel guest demands, considering the current technology trend, how to design the network architecture, and how to fulfill the network security requirements. TC Lee is an APJ Consulting Systems Engineer at AP Aruba, and is also a member of Certified Wireless Network Professionals. He has been involved in wireless deployments in many verticals, notably hospitality, service provider, education, and transportation. He has vast experience in design, deployment, and troubleshooting of wireless lines for the past 12 years. Now, welcome TC, and at this time, I will turn the floor over to you.
Hi, good morning, ladies and gentlemen. And I'd like to thank HFTP for the opportunity to share on this topic on hotel wireless networks and security issues. Just let me bring up that slide, and we're ready to go. So in this session, we will examine some trends in hospitality that will impact our technology investment, and we'll look at some misconceptions in Wi-Fi deployments and how we can develop best practices through understanding the technology. Now, it's critical that our investment allows us to build a solid foundation and infrastructure on which we can either enhance guest experiences or optimize our operations, or both. So whether we like it or not, IoT will be playing an important role in this aspect. But due to the inherent security challenges in IoT devices, it becomes a double-edged sword for this purpose. And in this session, we'll see that the traditional security solutions are no longer able to defend against threat posed by the vulnerabilities of IoT devices. Right, the learning objectives today are to understand some misconceptions there has been around Wi-Fi, and how many of the deployment mistakes tend to be made. Secondly, we'll see how Wi-Fi now provides more than just basic connectivity for guests. It can actually enable insights, engagement, and automation. And we hopefully will see that the value of Wi-Fi and the network infrastructure is not simply a sunk cost for guests. Network is now an integral part of a bigger overall strategy on which all digital initiatives will be hinged upon. IoT is going to provide tremendous benefits to hotel operations and a guest experience, but we need to be able to have an infrastructure that is converged, agile, and secure in order to take IoT adoption to the next level. Let's start by looking at some trends that are taking place. You may have heard by now that Hilton and Marriott have started testing IoT in creating their smart hotel concepts. Both of them are looking to transform the hotel room experience in different ways. Goals in both these two efforts were to see how digital technologies and IoT can create a hotel experience that anticipates your needs and personalize them for the guest. Both these efforts show that hoteliers are recognizing that the next generation of travelers are going to expect similar conveniences that they have at home with consumer home automation products. Hilton created a prototype of a mobile-centric hotel room where all the controls of the room is built into their Hilton Honors app. Known as the Connected Room, Hilton demonstrated how guests can control almost every aspect of their room via the app. Guests can stream their preferred content from various accounts on the TV. The app allows them to book and choose their rooms, very much like the way we book an airline ticket and choose our seats. And it even assigns digital room keys to their mobile devices. So this implementation serves not only to make technology intuitive for the next generation travelers, but also serves to enable better efficiency and energy savings by making the rooms smarter about the environment and the people in the room. Marriott, on the other hand, has teamed up with Samsung and Legrand to build a concept guest room called the IoT Guest Room. Using mobile and voice-enabled technology, the concept guest room allows guests to set up the room to best meet their needs. And the goal was to create a home away from home. At the core of this initiative is what they believe to be human behavior and expectation. And really, Marriott aims to allow guests to bring their personal identity into the room and add the ability to remember past behavior in order to anticipate needs. By making IoT integral to the hotel room, both Marriott and Hilton are now able to create a personalized room for each guest. They are also able to get better energy efficiencies by putting the room into a sleep mode when guests are not in the room. And at the bottom of all this is really, the ability to convert various other protocols for the HVAC systems and the AV systems into Internet protocol that allows these different systems in the room to be able to communicate and therefore can be orchestrated from an intuitive interface such as a mobile app or a voice-enabled device. If we wish to transform the guest experience, one of the first requirements is to be connected. Now, it appears to be pretty much inevitable, right? We have to deal with the next generation of travelers that has very different expectations and needs. In order to realize such a vision, people and things need to be connected. This is where the type of infrastructure we build becomes important. The ability to connect devices via Ethernet and wireless becomes fundamental. Enabling a smart room also creates the need to interconnect the guest network and parts of the back of house, and therefore a converged infrastructure becomes one of the requirements to achieve that capability. The next requirement for transforming the guest experience is personalization. For personalization, there must be a means to create and store customer profiles and to access them when required securely. Power of personalization has long been a key pillar in the hospitality and service industry. The essence of hospitality is in building of relationships, and that is a very personal thing. In knowing people and making them feel at home. People may forget what you said, may forget what you did, but people will never forget how you make them feel. Obviously, this goes beyond technology. Technology alone doesn't define hospitality, but technology can help enhance the guest experience and go a long way to make guests feel at home. When it comes to understanding hospitality customers and meeting their needs and winning their loyalty, we pretty much no longer have a choice. Customer obsession, means not only focusing on customers, but providing what they demand and what they expect. So the new reality is that customers expect us to be watching them, to be learning their preferences and earning their business. And they expect personalized service here and now. It's no longer realistic to think that a hotelier could rely on 20th century advertising and the same old loyalty programs and expect travelers to keep coming back. Third requirement for transforming guest experience is intelligence. But we can't expect to enhance guest experience just simply by allowing guests to control the environment. That becomes, a different way of doing things, that's all. But a good experience comes from the fact that the hotel knows you and your preference understands your mood and know when to offer something appropriate for that moment at that place. That is pretty much what Marriott is trying to do in creating that concept. By having the element of intelligence, knowing your past behavior, learning what you like best in the situation that you're in. So that layer of intelligence is required on top of the ability to manage IoT devices and allowing user interactions. These three characteristics are fundamental and to be effective in transforming guest experience. And let's take a look at how these requirements are affecting the networks we build. Now, traditionally, most hotels maintain two separate networks for guest and back of house. This had been done, firstly, in order to outsource the guest network to managed service providers. And secondly, to maintain PCI compliance in a more sensitive back-of-house network that contains customer data. Guest users are pretty much confined to the guest network, with all devices typically allowed to join, but these devices must be browser-based due to the captive portal login nature of guest Wi-Fi. And on the back-of-house network, usually staff are the only ones allowed to connect, and devices are mostly personal computers and points of sale systems. So there is an explicit trust relationship on these two networks, the guest network being treated as untrusted and the back-of-house network as trusted. Now, in order to support IoT and to enable an intelligent, personalized space, the network now pretty much has to interconnect not only the guest and the back-of-house in order to access customer profiles, but also to the HVAC and the smart TV system. The type of users and devices that require connectivity will now expand to include IoT devices, IoT controllers, next to HVAC primarily, and media devices that connects to AV equipment. So the network infrastructure will now be populated with not just guest devices, but staff and many others. This itself presents a security risk that needs to be taken seriously. Now, clearly, another way to build this is to create a totally separate physical infrastructure using separate access points and switches, but that is extremely costly to build, and it gets us into a more complex interfering RF environment. This is also where it imposes additional requirements on the network to provide what we call true dynamic segmentation, understanding the type of devices that are connecting in order to establish a trust relationship with that device and tunnel traffic securely in an encrypted manner to the appropriate network segment. Now, the key benefits to a connected hotel are that it enables a slew of possibilities that covers personalization to automation to operations. Guest room automation becomes possible once we have IoT connecting HVAC systems to IP networks. And once we have those HVAC systems connected, we can do predictive maintenance. And therefore, energy management becomes a lot more easier, and we can do it smarter. And with the systems on IP networks controllable by apps, we are then able to go beyond just connectivity, but also provide some engagement and achieve personalization. And interestingly, the ability of the network to know where you are adds a new dimension to personalization and engagement. So location awareness is another interesting dimension to this conversation. And with the ability to control things by apps, it also means it is possible now to use other more natural user interface technology, such as voice, to provide additional way for guests to get what they want. Now, all these trends leverage IP networks, both wired and wireless connectivity. So we'll next look at specifically, on the wireless technology side, some of the challenges and misconception about it. Right. Back about 6 years ago, when I was a hospitality SE, I spent a good number of years troubleshooting, hotel Wi-Fi networks, and I've seen many hotel IT showing me their guest satisfaction index, and the number 1 and number 2 complaints were always about internet, which mostly directly translates to Wi-Fi. And even today, I still see some hotels making mistakes in their Wi-Fi deployments. And these are not really the hotel's fault because, they have contracted a service provider. They engage them to deploy and to manage the guest Wi-Fi for the hotel. But I still see mistakes, happening. And we can see in social media and in online travel agencies' websites about ratings of hotels and their Wi-Fi, and how this is affecting consumer decision-making behavior when choosing hotels. So the question on this slide says, can you afford not to deliver stable Wi-Fi? Well, interestingly, there are many quotes out there, and I think there's a consensus that Wi-Fi is almost as basic as water. Same way that a guest expects that water will flow when the tap is turned on, the guest also expects Wi-Fi to be available and good when they connect. So one of the interesting, directions that I would love to see the hospitality industry go is really how we can make it frictionless for guests to connect to Wi-Fi and be able to seamlessly move from property to property without having to re-log in over and over again. Right. And also, with IoT coming into the picture, we're going to get some IoT devices that will need Wi-Fi connectivity in the room. Just think of Amazon Echo. As far as Wi-Fi connectivity, there's no Ethernet cable at all. So if we're going to provide voice-enabled technologies in a guest room, how would the connectivity happen? Which Wi-Fi would it connect to? How secure is that Wi-Fi? And how then could we not have an always-on stable Wi-Fi? In fact, we need it more than ever. Can't afford for the Wi-Fi to actually go down. So in the quest to provide the best Wi-Fi experience, I'd like to examine some misconceptions that I've encountered working with many hotel customers. So one of the first that I'm going to bring up is about blaming the bandwidth. So I'm quite sure some of you out there may have seen this or experienced this. You get guest complaints about slow Wi-Fi during the evenings, right? Doesn't happen during the day, right? You get the complaints pretty much in the evenings for everybody. All the guests are coming back to the hotel room and getting on the network. So you call up your hotel IT and your service provider and you demand an explanation. And they say, our internet bandwidth is insufficient. We need to buy more bandwidth. You take their recommendation and buy more bandwidth. But still, the guest complaints doesn't go down. Is this really a case of guest insatiable demand for bandwidth? Well, I've discovered that in many cases, RF channel, radio frequency channel congestion is the main cause of slow Wi-Fi. What happens is that during installation and user acceptance testing, the results are very good. That's pretty much because that's done at a time when there are few guests. But when guests occupy the room and start using the wireless network, congestion happens very rapidly. So what we get is what appears to be an unstable Wi-Fi network with inconsistent user experience. And I would love to hear from you, if you guys are seeing this kind of thing still happening out there in some of the hotels that you've been to. We will examine a little bit more about RF channel congestion in a bit more details later. Here's another example, which happens pretty often, quite common. It's the kind of situation where you can see the Wi-Fi network. Okay, the SSID is there. The signal is relatively strong, but when you try connecting to it, you have trouble. It's taking a long time. You can't connect. You get kicked out. You have to try to join again. You don't get IP address. And what do? We will complain. We will blame the access point. It's not so good. It's not a good access point. And we call the IT and we talk about Wi-Fi being bad. So this is kind of interesting because every customer that I meet with will demand that the access point cover a large area with strong signal. That becomes kind of the criteria for vendor selection, almost the sole criteria. And this is because the number of APs required will be fewer, and hence the cost of ownership is lower. This is a question I get so often that I formulated another question to answer that question. So if you ask me how far the access point signal can go, I would like to ask you, how far away do you think the access point can hear my mobile device? Get the idea? So what I want to stress here is that range, the distance between the access point and the device, the mobile device that we're using, is dependent on both the receive sensitivity and the transmit power of both devices. It's not just the AP. This is where a lot of customers fail to understand that the client devices that we use have different transmit power and receive sensitivity than the AP. So the analogy will be sort of like if I am in an auditorium and I have a mic and I have speakers, so my voice is amplified. And you, as a receiver in the audience, can be far away and hear me. Now, you do not have a mic, so if you like to raise a question, the problem is that I might not be able to hear you. So the distance between you and me would only be as far as I can hear you. And it depends on your volume, which is your transmit power, really, as well as how good my ears are, which are my receive sensitivity, which is my receive sensitivity. So there are a few other reasons that too much transmit power on the AP is not always a good thing. One of them is that it'll actually create more interference to your other nearby APs. And this can cause co-channel interference as well as channel congestion, which is going to cause you to fail to connect because the channel is so busy that your transmission doesn't get to the AP. The other reason is that it'll cause client devices to fail to roam to another AP. This is because the client thinks that it is still not far enough from the AP. So there is no trigger to start the roaming process, right? Now, I believe many of you might have seen pictures like this on the screen in your proposals for your wireless networks. These are Wi-Fi heat maps generated with professional tools, software tools, such as Ekahau and AirMagnet. And it's a very popular tool, and they're pretty expensive. Okay, and in both this heat map, it shows, everything is nice and green, the entire building is covered, and all looks good. Okay? I'd just like to share a word of caution regarding reports, like this, and heat maps like this. And you might be shocked by it, okay? Do not totally trust them. I say again, do not totally trust them until you know it has been validated. Why do I say that? One, in many cases, customers ask for such a report for the sake of estimation. And when this happens, this usually happens for properties that are being built, right? The building is not there, so we can't do site survey. And basically, the conversation goes something like, you can't do site survey right now because the building is not ready, but can you send me a predictive model quickly so that I can get an estimation on the number of APs required? But such an estimation, unfortunately, seldom ends up well because the real-life environment and what is modeled in the software is totally different. So we get a very, a misrepresentation. The second reason that I do not totally trust them is because such tools typically use a Wi-Fi USB dongle to measure the signal. Now, the issue here is that the receive sensitivity of the Wi-Fi USB dongle is different from the mobile devices that we use. Hence, the reported readings will be different, and you end up with a report that misrepresents your coverage. These tools typically have a way to calibrate, and if the user of the tool doesn't calibrate them, then the resulting heat map is no longer representative of your environment, as seen by your typical client device, such as our mobile phones. These are the hidden dangers in reading some of these reports. They tend to look too good to be true. And I've seen it with my own eyes. Service providers and partners that use the tools to measure, get a reading, and the reading is pretty off. Totally doesn't represent what my mobile phone is actually, reading. So what I recommend hoteliers is that you incorporate a process to get your personnel, your own IT personnel involved in a site survey to validate a few readings using a couple of mobile phones. All you need is just a few reference reads to ensure that the tool is calibrated. And what you're getting on the tool and what you're getting on your mobile device are similar. It doesn't have to be the same, but at least you get a better representation of your environment. Lastly, blame the building. So, okay, this is not quite a misconception, but rather instead is the truth. Every building is different, and hence the way RF signal goes through will affect how you design your network and place your APs. It's interesting that for service providers to scale up their deployment, they need to have what we call a standard design so that they can, use cookie cutter method to deploy. And that makes sense, and there's nothing wrong with that. What I would recommend is that your service providers use site survey results to determine the design. And this way, you optimize your design and investments for your type of building. The reason I say this is because most hotels or chains will have some guidelines that says, for 4- and 5-star properties, have 1 AP per room. For 3-star properties, use APs in alternate rooms. And for budget properties, put APs in hallway. So these guidelines are perfectly fine, right? But I like to stress is that you want to ensure that the service providers, pick the design that's appropriate for the building, not just for the type of property, but for the building. And also to perform a post-install RF environment check. And this is to determine if the level of co-channel interference will require radio configuration tuning. Because if we don't do that, you're going to get, radio congestion or channel congestion. And, even if you put 1 AP per room, the result is going to be bad. And I've seen it actually happen with hotels that decided, okay, let's go full Monty and put 1 AP per room. And they end up with way too much interference because of the size of the room, the nature of the walls, and signal going through easily. I've even seen some hotels go the other extreme by installing 2 APs in a single room. And this creates just way too much core channel interference. And really is kind of a waste of money because you spend a lot, but you're not getting any better results. So let's take a look at what RF channel congestion is and how this is going to affect the way we look at designing our networks and what is optimal for our building. So RF channel congestion is when many devices are using the same or overlapping frequency that causes congestion on that frequency. Why does it even happen? Don't we have many channels to use? You may ask. Well, let's take a look at this diagram. This shows Wi-Fi access points in 2.4 gigahertz. Now, I'm going to use this to illustrate the concept, even though today in Wi-Fi we use primarily 5 gigahertz. But you'll soon see that this problem can also occur at 5 gigahertz, although it is less severe. So in this diagram, I have one AP operating on channel 1, 3 APs operating on channel 6, and 1 AP operating on channel 11. So I have a total of 5 APs. Okay? And the reason I'm just discussing about 3 channels here is because these 3 channels are the only non-overlapping channels available in 2.4 gigahertz spectrum. So in this deployment, let's just say we have 2 users on each AP. Okay? So what this means is that on channel 1, I would have a total of 3 devices. Why 3? Well, the AP is 1 and 2 users. So there are 3 devices on the same channel. This is a fact, right? In order for the users to connect to that AP, it must be on the same channel as the AP. So with the same reasoning, how many total devices do we have on channel 6 and channel 11? Can you do the math? Well, we have 9 devices on channel 6 and 3 on channel 11. Okay? So I hope you figure out the math, okay? If you don't, we'll have another round in a while. Now, we need to understand that Wi-Fi uses a shared medium. Most radio protocols are the same. So the way to understand this is to think of a walkie-talkie concept. Everyone uses walkie-talkie. They tune into a specific frequency, and they communicate one at a time. So for the AP and the devices on that channel, it's like a walkie-talkie group. Right? In our Wi-Fi scenario here, the 3 devices sharing channel 1 is like a walkie-talkie group on that frequency, on channel 1. And then in channel 6, we have 9 devices. Why? We have 3 APs and 2 devices per AP. So the number of devices connected are 6 plus the 3 APs themselves, a total of 9. I hope you get that. And then on channel 11, 3 devices as well. So what this means is that channel 6 is somewhat busier than the other 2 channels. Okay? So at this point, the congestion is not such a big deal, right, to be honest. But what if we increase the number of users on each access point and bump it up to 6 now? How many devices total would we get on each channel? See if you can make a guess. Okay. And see if you get it right. Now, in this case, if we bump up the number of devices on each AP to 6, each device, where each AP has 6 devices connected to it, then channel 1 would now have 7 devices, right? 6 attached to the AP and 1 the AP itself. That's up from 3 devices. Now, channel 6 would have a total of 21 devices. In 6 per AP, so 6 times 3, and plus 3 APs themselves, a total of 21, up from 9 devices. And channel 11, same thing, 7. So the effect on channel 6 is becoming obvious. It's getting congested. Those users on channel 6 will now start to feel that the network is slower than before. while users on channel 1 and 11 will feel that the network is still good. So with every additional user on the channel, the congestion effects multiplies. In RF terms, we use the term channel utilization being saturated. We use the term high duty cycle. We use the term co-channel interference. So you might ask, what is the tipping point? How many users before it gets, obviously bad or obviously good? Now, the answer is that there isn't a hard number. It is dependent on the type of devices. It is dependent on the location of these devices with relation to one another. And it's dependent on the type of traffic that is being sent. So really, it's a case of shades of gray. One way to think of it, we have on channel 6 is 25 devices total. But, if most of the devices are silent, meaning there isn't a lot of activity, there isn't a lot of transmission, then there is no interference, there is no congestion. So there may be a few devices that are actively transmitting, downloading stuff, and they probably wouldn't feel it. All right? So there's a lot of dependency on, what's sort of activity is happening. Okay? The minute every one of these devices starts to pick up the activity, that's when the congestion is being felt. All right? One of the killers, performance killers, is when some or all of the access points uses what we call white channels. Okay? Now, the Wi-Fi protocol allows for 2 or more channels to be combined to provide better bandwidth. This is great for home use, but this causes a huge interference issue in a multi-AP deployment like a hotel. And the picture on the left shows one AP using channels 8 plus 4. And you can see how the signal overlaps almost every other channel. And this AP alone will create interference enough to cause every other user on all the rest of the APs to find the Wi-Fi unusable. Don't know if any of you have been to China. A lot of the hotels in China or service apartments, use consumer-grade APs with this sort of deployment, which is exactly what the picture on the right is showing. The picture on the right is a deployment by a service provider at a budget hotel using consumer-grade APs that are all using white channels in 2.4 gigahertz. Wi-Fi was practically unusable. And practically all the consumer-grade APs will have white channel enabled as default, and some do not even allow you to configure otherwise. Now, this can actually happen in 5 gigahertz spectrum as well. Yes, surprise, surprise. Well, in some countries in Asia, the regulatory domain restricts the use of some parts of the 5 gigahertz spectrum. So your deployment will have limited number of 5 gigahertz channels to use. And many enterprise-grade Wi-Fi equipment defaults to 40 megahertz channel width or 40 megahertz white channel, which is actually 2 channels combined. Some cases, the default is 80 megahertz, which is 4 channels combined. And so what we get is a similar result in 2.4. You could get congestion on the channels when the number of users increase. So this particular screen or slide is showing a screenshot from a ballroom in Macau. And that was an event happening. There was a conference happening with 400 users. There was a total of 7 APs. You can pretty much count the lines on that screenshot. Okay, 7 APs under normal circumstances. That 7 APs would be sufficient to take the load of 400 users. But because the APs were on overlapping channels, 3 of the APs were on overlapping channels on one of the channels, and then the other was 4 APs overlapping. And at the same time, there was a rogue AP operating using an 80 megahertz white channel, which basically interferes with both, in fact, interferes with all the 7 APs. The result of it was the Wi-Fi became so slow, it was unbearable. We could use it. It's just slow, way slow. And these were not internet bandwidth issues. They were caused by design and configuration faults. So what causes all that congestion and co-channel interference? Well, the two reasons. Number one is design. The other is configuration. Now, in the previous example that you saw at 5 gigahertz, if the APs were configured to be using 20 megahertz channel, it would mean that they would have a lot more APs, or 4 more channels rather, to use, spread across 7 APs. Okay. So anyway, I'd like to address the design issue as this has the biggest impact. And design here simply means where we decide to put APs. Specifically, this impacts the most the design for Wi-Fi in the guest rooms. Okay, so let's consider this arcane design number one, and I think you may find it familiar, right? This is something that was very popular in the past, and I'm just using it to illustrate the concept of congestion. Okay, we're using 7 APs to cover the rooms on this floor. In this case, those little round dots, they are the APs. And again, I'm using 2.4 as an illustration. Again, this can happen in 5 gigahertz if we have white channels. So in this case, we have 3 APs on channel 1. Okay? And one of the problems in this AP placement is that the APs on the same channel along the hallway contribute to channel congestion because they are within range of each other, the hallway being open with no obstruction whatsoever. So when one AP is transmitting to user in their room, the other 2 APs can hear that transmission and detect the channel being busy. Hence, they would have to wait till the channel is clear again. And this is, what we call co-channel interference. You probably would also hear the term that describes the situation and as an exposed node. Okay? Now, note that this problem extends not only to APs on the same floor, but it also affects the APs on the floor above and the floor below. The signal is usually able to get through from the first, to the top and to the bottom. There's a second problem with this design. Because the APs are placed in the hallway to provide access to rooms on both sides of the hallway, the problem that this design brings is that the users or devices on one side of the hallway are not able to hear the users on the other side. Right? Interesting. This leads to collision at the AP. What it means is that the AP will potentially receive signals or transmission from users on both sides. And this condition is also known as the hidden node condition. In case you get confused about this, just like to remind you that Wi-Fi works like walkie-talkie. All right, so for a user to talk, he has to wait for the channel to be clear. And to know that the channel to be clear, he has to be listening in to all the other users. So if it happens that 2 users hit at the same time on the walkie-talkie, what will happen is that you will get confusion. You can't pick up the conversation. You don't know what both of them are saying. So it's the same thing in this situation because the users on both sides of the hallway are separated by too many walls and bathroom, and all the fixtures in the bathroom. So you potentially get this scenario where, the users on both sides, the devices, cannot hear any transmission from the other side to the AP. So I do have a specific test designed to determine if a hotel can use this design, right? Now let's take a look at a second design option. With this design, we have now moved the APs into the rooms. Instead of covering 6 APs, now each AP covers 3 rooms. You will find that this design will provide better Wi-Fi stability with user load than the previous design. Not from the point of view of the number of rooms covered being less. The reasons are because once the APs are inside the room, the walls create isolation between APs of the same channel. So if you look at the pink color areas, which is all channel 1, the APs are separated by a bunch of walls that prevents co-channel interference from happening. So this enables channels to be reused without causing congestion. In other words, very little co-channel interference. And the second reason is this design produces or introduces far less collisions because users that are connected to the AP are nearer to one another and separated by fewer walls, and hence they're able to hear each other's transmission and know when they can take their turn to transmit. So even though the AP is covering, appears to be covering only 3 rooms, in actual fact, it may well be covering 5 rooms due to the signal being able to get to the floor above and to the floor below. So it really depends on the building materials and therefore needs to be tested. But this design will work better when all guests start using the Wi-Fi network during the peak times. But for this particular design, you'll find that the bathroom coverage could be poor. In fact, it's likely to be poor, right? Because you have that crossover to the next room, and you have that bathroom walls that are going to attenuate the signal even further. So how would we know, or how do we know what design is best for a hotel? And how do we know if our service providers are proposing the right design? So I have a few tips that I will share with you. And I think the first most important thing is that your service provider must be able to articulate rationale for their design. And as a first rule of thumb, I would recommend, done so for many hotel chains, you have 1 AP every room. And there's a reason for that. It's not purely from an economics point of view. Okay? This is where you want to start with to be on a safe side. Now, the other thing is to ensure that you get your service providers to do site survey for both 2.4 gigahertz and 5 gigahertz separately. And request for a site survey that measures not just signal, but as well, but throughput from a mobile device to the AP from different parts of the coverage area. All right. Any survey done with a professional Wi-Fi tool must be compared with readings taken from several different models of mobile phones. In fact, I recommend that you could just actually do a site survey with a mobile phone. And make sure that you ask for a site survey report that will produce the results separately, heat maps and quantitative results for both 2.4 gigahertz and 5 gigahertz separately. They should not be combined, because by separating them, it gives you a better picture of your coverage areas for both the spectrum. And it will enable you to be able to manage your network for various different types of device connectivity, including IoT devices. Now let's move on to talk a little bit about security. So IoT security has been described as an accident waiting to happen. Also, pretty much this is a report from 2017, so it's really over by now, but basically what we're saying is that we are basically having to look forward to potential IoT breaches on a large-scale basis going forward. And this is because smart device manufacturers have been, releasing products without really securing them, and very often the kernel systems are left with default embedded system passwords. And now we are connecting these devices on the network, and that has made those devices vulnerable. January 2017, C Hotel in Austria, their key-making machine computer was hacked, and they could not program key cards to issue to guests for checking in. And the hackers asked for bitcoins in return for releasing those machines. Interestingly, it was their fourth hacking incident. They never reported the previous ones. At that time, the Bitcoin was valued at USD about $1,000. Now you know how rich the hackers will be by now. And in October 2017, Hyatt announced that their payment systems was hacked by cybercriminals, resulting in loss of credit card details affecting 41 hotels in 11 countries, with the worst hit in China. And this was the second security breach in 2 years of the same nature. According to the investigation report, malicious code was injected into third-party software that they were using. And in July 2017, a casino in North America was hacked through a smart fish tank. Hackers got into the smart fish tank and moved laterally to other parts of the network and started extracting data and sending it to Finland. I'm sharing this incident because in the past, the attack surface are mostly computers with weak security, as in the case of C Hotel and Hyatt. But with the recent breaches, they are through IoT devices connected to the network. I wonder if any of you have watched the Korean movie, The Train to Busan, the zombie movie. And there were a couple of scenes that I thought, illustrated very well the world we are in today. Because the webinar system doesn't allow the playing of movie or animation, I have taken some screenshots to share with you. And in this particular scene that you're seeing on the slide, the survivors were trying to get into a safe zone in one of the train cars, away from the attacking zombies. We're trying to lock the door, but the lead character said that he thinks the zombie doesn't know how to open the door. And why is that the case? The zombies were attacking them because they see them. So this is a perfect illustration for the risk that IoT brings to our network. When we plug IoT devices into our network, we essentially expose our network to vulnerabilities. Now, the hackers can see us through these IoT devices. So this is where your network needs to be able to have the security features to be able to do what we call segmentation through tunneling, not just simply by putting it on a VLAN with a network. Unless you wish to take the approach which C Hotels took, which is to shun the use of IoT and technology totally and go back to old-fashioned keys, we need a different approach to security. Attacks are changing a lot more rapidly than traditional defenses can combat. At the same time, our digital assets continue to increase in value. The kind of data that we store, the kind of data that we transmit is increasing in value. And hence, the vulnerability and the risk are high. And mobile and IoT are breaking down the traditional defense parameters. You can have firewalls, you can have antivirus to get in. So they are no longer sufficient to just protect your network based on the parameter defenses. And any signature-based security solutions are also no longer be able to detect and scale and mitigate the new style of attack. How do we protect ourselves if we plan to adopt IoT? We need a new security model to address the use of IoT. Security model that allows us to gain better visibility into what devices are on our networks. This goes beyond the MAC addresses and the IP addresses. We need to know the type of devices. And we need a way to manage access policies for each class or type of device. Rule-based access control that uses source and destination IPs or MAC addresses are not going to be scalable, handle IoT adoption. We need a way for us to establish trustworthiness of a device or a user on a network, and we need a way to do segmentation and containment for the device. We can't rely simply on credentials. In fact, many IoT devices do not even support credentials or strong authentication methods, such as WPA2 Enterprise. And we also need a way to monitor the behavior of users and devices on our networks to be able to detect suspicious or malicious behavior. So the next big thing is user and entity behavioral analytics using machine learning and artificial intelligence. That would be the new security mechanism to be able to effectively deal with threats in the IoT era. So hotels will need to exercise care in vendor selection for IoT solutions and network solutions. It's important to ensure that you use enterprise-grade products and solutions, and vendor selection for both IoT and networks should be based on their security position and features. Networking vendors that support true segmentation using encrypted tunnels rather than simple VLANs will offer better security for deploying a converged network that's going to carry IoT traffic. Dynamic segmentation based on the device types works on both the wireless and the wired connections will also provide better security that's needed for containment of IoT devices. Vendors that have built-in firewalls in the solution will add an extra layer of security to prevent cross-contamination of network segments at the point of interconnect. And vendors that has behavioral analytics capabilities will provide greater peace of mind, as this solution uses machine learning and artificial intelligence to detect abnormal and suspicious behavior in the network. And better still, if you can find a vendor that can provide closed-loop protection, is not only detect, but to respond automatically, that will be ideal because it eases the burden on hiring highly skilled security personnel to monitor and assess threats in the network. In summary, I think Wi-Fi is a technology we'll be living with for many years to come. So we really owe ourselves a favor to be more aware of the technology and its behavior so that we know if it's being deployed effectively. IoT is here to stay, and it's going to play an important role in our lives going forward. But due to its inherent risk and vulnerability, the networks we deploy will no longer be simply based on coverage and how strong Wi-Fi signal is. We need to look holistically at our networks we build to enable the integration of various IoT devices. It's no longer just for guests. And we'll need stronger security features in the networking solution that allows true segmentation and containment of users and devices with unified policy management that works over both wired and wireless connections. We also need to continually monitor the behavior of our devices and traffic in the network. All right, with that, I've come to the end of my presentation. Thank you very much. Over to you, Trevor.
Very good. Thank you all for joining us today. Before we close out, we do have a few quick polling questions that we'd like to ask the audience. Why is it a bad thing to have several APs on overlapping channels? The options are client devices take longer to detect them. The second option, they interfere with one another and cause congestion. And the third option allows an attacker to hack into them faster. Please select the option you feel is the best fit on your screen, and then click Submit. We'll reveal the results in about 15 seconds. All right, at this time, 100% of attendees have selected the second option. They interfere with one another and cause congestion. Well, that's the correct answer. Moving on to the second polling question. What is the reason we get RF channel congestion or co-channel interference, assuming no external APs or interference? There are three options here. Because the Wi-Fi design and or configuration was incorrect, because we did not install enough APs, or because we installed the APs in the closet. Give everybody about 20 more seconds to fill out this polling question. Please select the best option and click submit. All right, very good. At this time, again, 100% of attendees have selected the first option because the Wi-Fi design and or configuration was incorrect. And as you can see on the screen now, that was the correct answer. And the third polling question. What is the best way to secure our network for IoT devices? By deploying plenty of firewalls and antivirus, by changing the kernel of the IoT devices to a secure version, or by deploying access control solutions with behavioral analytics? We'll give everybody about 20 more seconds to fill out this polling question, and just like the last two, select the answer you feel is the best fit. All right, a little bit of a split result here. 25% of attendees selected the first option by deploying plenty of firewalls and antivirus. 25% of attendees selected the second option by changing the kernel of the IoT devices to a secure version. 50% of the attendees selected the third option by deploying access control solutions with behavioral analytics. For this poll, the correct answer was C, by deploying access control solutions with behavioral analytics. Well, we do have a few minutes for questions and answers. We have the first question that came in today. What is dynamic segmentation and how does it work?
So dynamic segmentation happens on a switch port. Typically, when you connect a device to a switch port, it gets an IP address from the network and it's assigned a specific VLAN on that switch port. Now, that VLAN could be static or dynamic, but the traffic gets into the switch port, into the network from there. Dynamic segmentation does tunneling for the traffic from that port. So when the device is plugged in, what the switch does is it tunnels the traffic to the controller, the WLAN controller, the firewall, in order to do device profiling, meaning that we identify what kind of device is coming on board before we decide where to send the traffic to. So if you plug in different devices to the same switch port, it's going to be able to, for us to detect and therefore assign the right role to it, and then allow it to get into a particular network that it's meant to go. So it is a tunneling technology used to provide security at the switching level. And this is important because don't forget that the devices that are connecting into the guest room are likely to be on the untrusted network segment that is managed by a service provider. So you want that traffic to be tunneled in securely to your internal network, to the HVAC system, in order to be able to contain the device within that network segment.
Very good, very good. And the last question we have time for tonight, regarding RF channel congestion, how many users would it take to cause the Wi-Fi to be slow, and is there a threshold?
Well, the answer is it's kind of hard to put a number on it, but typically in 2.4, you're looking at about 30 to 40 users as a range. At 5 gigahertz, you'll be looking at probably double the amount, around 80 users as a range. Now, obviously, it's going to change with the technology, and it's also going to change, with the kind of devices and the kind of traffic that you're expecting to, allow these devices to get through. So the kind of bandwidth that you allow for each devices will dictate or impact the number of users you can, allow for that channel to reach the congestion level. So, but from a channel perspective, when we look at the channel utilization, we like to keep the channel utilization around the 50 to 70% range, okay? Because anything higher than that, users are going to feel an impact, noticeable impact on their access. All right, so this is typically a situation where you get in convention, ballrooms, conferences, exhibition, and stadiums, where a large number of users are actually trying to connect, and the channel becomes saturated very quickly. So it gets to a point where it becomes kind of unbearable or a little impact. So the channel planning is important. What kind of channels we use and how wide the channels are going to be, and how we separate them in order to be able to reuse the channel without causing congestion. These are all part of the planning process and the design process. So there isn't a number that I can be definitive about, but those are the sort of benchmarks or range that we're looking at. 30 to 40 at 2.4 gigahertz, and about 60 to 80 at 5 gigahertz.
All right, perfect. With that being said, we have no more time for questions. We'd like to thank you very much for joining today's presentation. An archive will be ready over the next couple of days for you to review. And with that, we thank you all for joining. We hope you all have a great afternoon or night, depending on where you're dialing in from. Thank you.
Thank you, and bye-bye.